Okay, so let's solve problem 55 jump game. And before we solve it, we have to make sure we understand the question properly. So each element in the array represents your maximum jump length at that position. So what that means is if we have this 3 here, it means you can either jump 1 step or 2 steps or 3 steps. Okay, and we return true if we reach the last index. So as I said, suppose this one was 4. If it goes, even if it goes beyond the last index, because it has an option to jump once, we can say it's true. Otherwise, if it didn't reach the last index, it means it's false. So let's think of a scenario where it can reach the last index. And before we do that, we have to have a pointer which represents how far we can go. So it's the furthest point we can go throughout the iteration. So we're gonna have a num star I as usual, which represents the current index. So we're gonna initialize furthest to 0. And what we're gonna do is we're gonna say if the nums I, which is 1, plus the plus I, which is the current location of an element, if they are greater than furthest, we're going to move the furthest pointer to that location. So it will be simple. If the num star I plus I is greater than furthest, we're going to move furthest to that point, to this point here. Okay. So in our first iteration, the furthest will go here to the second element, and then we're gonna do the second iteration. And when we look at it, the num star I, which is equal to 3, and then the current position I is equal to 1. So it is 4 is greater than our current furthest, which is equal to 1. So our furthest point will go all the way up to here. And then we're gonna carry on with our iteration. It will take us here, so it's not good, it doesn't satisfy this condition, so we're gonna move on to the next iteration. Here it does satisfy, so we're gonna move our furthest pointer to here. And then when we go to the next iteration, it says it can go 4 points from here, 4 steps. So 1, 2, 3, 4. So it's going to be out of an array. Well, out of an array, but technically it can stop at the last index. So in this case, it has reached the last position of an array. So that's the first condition. And then, so that means when, so how do we know when it has reached the last index? The success scenario would be if furthest is greater than the last, or greater than or equal to the length of an array minus 1, which represent this specific point here. So the question is, when do we know it has failed? Let's have a look at the example below. So we do have the num star I as usual, and then we have a furthest pointer. So it will go to here, and then our furthest point will go here, and then num star I will go here, and then furthest is equal to num star I plus I, so it will go to the next element, and then it will also go to the next element. Furthest hasn't yet modified or updated, and then the num star I will go here. So we do know that furthest pointer is stuck at this point. It can't really move forwards. So at this point, what we know that is I is greater than furthest. So when does it fail? It fails when I is greater than furthest. So we came up with all the logics. That's the condition for updating the furthest. That's the condition for checking if we has reached the last element. That's the condition. If we condition to check if we can't move the furthest pointer anymore. So the question is, where should we put this fail pointer? Well, it kind of makes sense. The success case so should come straight after updating the furthest. Well, let's think about it. If we have furthest here, and then if we check the failure after this point, doesn't really does it make sense? Well, let's see. If I is equal to 5, no, I is equal to 4, and then the current position is 0, and then for this hasn't yet been updated. It doesn't really matter where it goes, so we can put them in any order, but I'm gonna put fair at the end. All right, let's see what we can do. So we are gonna have int furthest is equal to 0 initially, and then we're gonna loop around int I equals 0, I is less than start length, and I plus plus. Okay, let's check. If I is greater than furthest, we return false. Okay. And then we have to update the furthest. So if furthest is smaller than numStar I plus I, furthest is equal to numStar I plus I, and then if furthest is greater than numStar length minus 1, we do know that we have to return false. And then the thing is, we do know that at the end of the for loop, it will either return false or this one has to be true, return true. But do we need to return anything at the end of the for loop? Well, there is an edge case. So if the number was just 0, then let's look at our condition. I is 0, so this return false does not meet. That's 0. The position is 0, and then the number is 0, so this condition does not meet. And for this is 0, numStar length is 1 minus 1 is 0, so 0 is not greater than 0. So none of those if statement condition meet. So we have to meet return false. Okay. And let's run it. And submit. Oh, why did I say? Oh, it has to return true. Because we have already, if the number is just 0, we have already reached the edge point, not the edge point, the end point. That's why we are returning true. So the runtime is 2 milliseconds. It beats 80% of people. Well, I looked up the solution that gets us almost 100%. It's literally doing the same thing, but it's doing from backwards. So I personally find this is more intuitive than going backwards, so I'm happy with this method.